Lecture 12. We're going to talk about dividing polynomials. Last class, we talked about rational expressions. So those ones are rational expressions as well. But we're just focusing on dividing two polynomials. So let's see the first question. So A, we see the numerator is a polynomial degree 3. The denominator is a polynomial degree 1. So the quotient should be polynomial degree 2. So what do? The numerator will have 4 terms: 12x cubed, negative 6x squared, positive 3x, and 1. The denominator will only have 1 term. We just divide each term in the numerator by the denominator. So let me write it out. So that's 12x cubed divided by 3x minus 6x squared divided by 3x plus 3x divided by 3x, then plus 1. Right, then we can simplify each one. So 12 divided by 3, that gives us 4. X cubed divided by x, remember is x raised by 1. So division of the same base, we subtract exponents. So we get an x raised by 3 minus 1, which is 2. We get 4x squared. Then minus 6 divided by 3, that's 2. X squared divided by x, that's x raised by 2 minus 1, which is just x raised by 1, which is read as x. Then plus 3x divided by 3x, something divides itself. That's just 1. So plus 1. Oh, sorry, I made a mistake. This is not a plus 1. Plus 1 divided by 3x. Then plus 1 divided by 3x. So this is a quotient. So this is a result of dividing those two polynomials. We see this is a polynomial degree 2, but this is a rational expression because the variable x appears in the denominator. So this is the answer for A. Now let's see B. B is the same thing. We're just dividing by negative 5x. So we will divide, let me write this one. We divide everyone by negative 5x, so I can cross this off. So it's the same as dividing everyone by negative 5x. So 25x raised by 4 positive. Positive divided by negative, we get negative. 25 divided by 5, that's 5. X raised by 4 divided by x, that's x raised by 1, by the way, okay? Always imagine that's exponent 1. 4 minus 1, 3. So negative 5x cubed. Negative 15x cubed divided by negative 5x, negative divided by negative become positive. 15 divided by 5, 3. X cubed divided by x raised by 3 minus 1, x squared. Negative, negative, positive. 30 divided by 5, 6. X squared divided by x, x. Positive 5x divided by negative 5x, negative 1. Negative 20 divided by negative 5x, negative, negative, positive. 20 divided by 5, 4. But then we still have this x in the denominator. Again, we see the result as a polynomial degree 3. Okay? Because we have polynomial degree 4 divided by polynomial degree 1. So that's polynomial degree 3. But then we have this rational part because the variable x appears in the denominator. Okay, that's dividing by a monomial. Like 3x is 1 term, monomial. Negative 5x, monomial. This is 1 term. Now let's see question 2. Question 2, we're dividing by a binomial. I need more space. Okay, so let's see 2. So we're going to perform something called long division. Long division. Let's do a number first. Maybe you have learned something like this. Let's see, if I have 120 divided by 3, right? That's 120 divided by 3. So if I use long division, I use this method, long division, I do this. I put the dividend to all the numerator, right? 120 divided by 3, I can also write this way. So in this case, I call 120 dividend, I call 3 divisor. In this case, I call 120 numerator, I call 3 denominator. So how do we perform long division? So I make this sign, looks like a square root sign. I put the dividend or the numerator inside the sign. I put the divisor or the denominator outside the sign. Then I take one number, so 1 is smaller than 3, so I need to take 2 numbers from inside. Then I think 3 multiplied by what? Let me change my color. 3 multiplied by 4, I put this 4 on top of 2. 3 times 4 is 12. Then minus 12, so I get 0. Right? Then this is 0. Well, this 0 I just pull up. So once I reach 0, I'm done. So that means 120 divided by 3, that equals to 40. Right? So if I'm not reaching 0, I'm going to keep going until the number is smaller than 3. So let's see this. We're going to do a similar thing for this. So we put the dividend, which is polynomial degree 2, inside the sum. So x squared minus x minus 6. Then I put x plus 2, the divisor, outside the sum. Right, the difference is here I have binomial, but here I only have one number. So I have binomial, so I'm going to take 2 places from here. So I'm thinking and matching the leading term. I'm matching with this. I'm thinking x multiplied by x will give me x squared. Right? X times x give me x squared. I want to match up with this leading term. Then I will do 2 times x, or plus 2x. Then I do subtraction, same as here, we do subtraction. So subtract from above. Well, of course, x squared minus x squared becomes 0. But if it's 0, we don't really bother to write it. Now I have minus x minus 2x. That becomes minus 3x. Now I take the next one down. Next term is negative 6. So I take negative 6 down. Now I think from x to negative 3x, I need to multiply minus 3. Because x times negative 3 gives me negative 3x. Then I will do 2 times negative 3. That gives me negative 6. So I subtract, I get 0, right? I get 0. So that means the solution or the quotient is x minus 3. We can verify this from another way. Remember in last class we talked about factoring? Look, x squared minus x minus 6. This can be factored, right? 2 factors of negative 6 adds up to be negative 1. It has to be x minus 3, x plus 2. Because 2 times negative 3, that's negative 6. Negative 3 plus 2, that's negative 1, because it's negative 1x. And then if we divide by x plus 2, we can write this way. We can write dividing by x plus 2 this way in the denominator, right? Then we see x over x plus 2 over x plus 2 becomes 1. So we're left with x minus 3. That's just to verify this long division. Well, let's see this one. We're going to do the same thing. We're going to make this sign, long division sign. Write the dividend inside. Minus 4x plus 3. and write the divisor outside. Let me change my color. Now again, I'm taking two terms and matching up x to x cubed. So I need to put the 2x squared here. So to multiply by x, get 2x cubed. So basically I have this one, multiply this one to give me this one. Because it's like an elimination. From the left-hand side to the right-hand side of the dividend, we eliminate one term by one term. Then I have to multiply 1 with 2x squared. So that's positive 2x squared. Then I subtract. Of course, 2x cubed, subtract 2x cubed, that's 0. That's my intention. That's why I put a 2x squared here, because I want to get rid of it. Now I have negative 3x squared minus 2x squared. That's minus 5x squared. Then I put the next one down to negative 4x. Now I need to put a number up here. Multiply by x gives me negative 5x squared. Well, that's negative 5x, right? Because negative 5x times x gives me negative 5x squared. Then I have to multiply by 1, multiply 1 with negative 5x, which gives me negative 5x. That's subtract. Of course, the leading term cancelled, right? Negative 4x minus negative 5x becomes negative 4x plus 5x. That gives me positive 1x. Okay? Negative 5x becomes positive. So negative 4 plus 5, that's 1 positive 1x. Then I pull the next one down, plus 3. Well, now I only need to put a 1 here. Because 1 times x gives me x. 1 times 1 gives me 1. I subtract. X minus x, of course, becomes 0. 3 minus 1, 2. And 2 is smaller than x plus 1. Because x plus 1 is polynomial degree 1, and 2 is polynomial degree 0. So I know I'm done. I'm done. How do we write our answers? We write our answers like, let me write the equal sign here. Equals to quotient 2x squared minus 5x plus 1. But then we have this remainder. So let add 2 over x plus 1. We have polynomial degree 2. We have this rational part, right? So when we do not get 0, if we get 0, that means this can be affected. If we do not get 0 as a remainder, so we know it's not x plus 1, it's not a factor of this dividend because we have remainder 2. How do we represent 2 as remainder? So 2 divided by the divisor, x plus 1. So we have polynomial part, we have rational part. Let's see this too. We're going to do the same thing. We'll make this sign. Put 2y squared plus 3y minus 9 inside. Then 2y minus 3 outside. We're going to take 2 terms. Sorry. I have something on the stove. I had to turn it off. Okay, we're going to consider 2 terms. Right, those 2. So thinking to put a y, let me change my color. We need to put a y here, because 2y times y, because 2y times y give us 2y squared. Then we have to multiply negative 3 with y, then negative 3y. Then we subtract. And of course, the leading term gets cancelled. 3y minus negative 3y becomes 3y plus 3y. There's 6y. Take the next term down, negative 9. Now we need to put a positive 3 here because 2y times 3 gives us 6y. Then negative 3 times positive 3, that's negative 9. Subtract, it is 0. It is 0. So that means this, so the answer is y plus 3. That means this one can be factored. That means 2y squared plus 3y minus 9 can be factored as 2y minus 3 times y plus 3. Right? But when the remainder is 0, that means the divisor and the quotient are factors of the dividend. Well, let's see this one. 3x cubed. Now we see something missing. We do not have square term, so we put a 0x squared. The 0 times x squared is still 0. So we need to take this spot. Then plus 2x minus 5. So we want to write a polynomial in order. X minus 2. Now we're going to do the same thing. So x to 3x cubed, we need a 3x squared. Then negative 2 times 3x squared is negative 6x squared. We do subtraction. It's cancelled. 0 minus negative 6x squared become positive 6x squared. Take an x down to x. Now we need to put a 6x here. 6x times x, 6x squared. 6x times negative 2, negative 12x. Subtract. This 2 cancelled. 2x minus negative 12x becomes 2 plus 12x. 12 is positive 14x. Move next down, negative 5. The x to 14x, I'm going to put a 14 here. 14 times x, 14x. 14 times negative 2, negative 28. Subtract. 14x minus 14x, 0. It goes to cancel. Negative 5 minus negative 28 becomes negative 5 plus 28. So it becomes positive 23. So this one also has a remainder. So we write the answer as, so this equals to, first, the quotient, 3x squared plus 6x, 6x plus 4, then plus the remainder, 23 over the divisor, minus 2. And we also have a polynomial part, polynomial degree 2, and we have a rational part. This is a very interesting when I move to this page. Okay, right here, question 3. So now we switch our gears to solve rational equations, right? Before what we just did is expressions. We use a long division to rewrite the expression. Now we want to solve rational expressions. There are different ways to solve this, but one way is to do this, to get rid of the denominators. Just like before, how do we get rid of a denominator? We multiply by least common denominator. Well, what's the least common denominator here? So 2x, well, 2 times x, well, this is x, this is 12. So least common denominator for this case is 12x, right? So the common denominator is a multiple. It's multiple. So least common multiple of 2x, x, and 12 is 12x. Then once we figure out, we just multiply every term by 12x. So let me just write 5 over 2x. We're going to multiply by, let me leave space. equals to 2 over x. We're going to multiply by, let me change my color. So for each term, because I have equation, so I can perform any operation simultaneously. So I multiply by 12 with x with this one. I multiply 12x with this term. I multiply 12x with this term. But this is as a numerator. You see, this 2 is in the denominator. So 2 simplifies 12 with 6. And the x divided by x becomes 1. So I have 5 times 6 times 1. 5 times 6, 30. That's how we get rid of the denominators. Now this one, I have x over x becomes 1. 2 times 12, that's 24. 24. Then minus this one, 12 divided by 12, that's just 1. 1 times x, that's x. Then I can move negative x to this side. Same time, I move positive 30 to this side. Negative x move to the right-hand side, become positive. I just rewrite 24. I'm not going to move 24. So 30, when I move to the other side, becomes negative. 20 minus 30, that's negative 6. So x equals to negative 6. Okay, now let's see B. Let's do C first, because B, I need more space for B. C, let's figure out the denominator. Least common denominator. So least common denominator. How do we figure out? X squared minus 3x. Let's read right here. X squared minus 3x can be written as factored form. X times x minus 3, right? Then x squared minus 9, that's the difference of two squares. That's x plus 3, x minus 3. So we have 4 factors. We have x minus 3, x minus 3 here, then x plus 3. So the least common denominator for this one is x times x minus 3 and x plus 3. So this one, this denominator is x squared minus 3x, which is x times x minus 3. So I need to multiply x plus 3 to make it. Oh no, I'm not going to do that. I'm not adding. So what do? I multiply both sides with the least common denominator of x times x minus 3 times x plus 3. Because I have equation, right? I'm not working with expressions, I'm working with equations. So I can multiply every term with the least common denominator. So when I multiply x minus 4 over, we read x squared minus 3x as x times x minus 3. Then let me leave some space, equals to negative 2 over, well, x squared minus 9 is x plus 3 times x minus 3. And what I'm going to do with this 2, I'm going to multiply by the least common denominator. The least common denominator is x times x minus 3 times x plus 3. Now, of course, I do on both sides simultaneously. X times x minus 3 times x plus 3. Now, this is a numerator, right? So let me use different color. I have x in the denominator, x in the numerator. X minus 3 in the denominator, x minus 3 in the numerator. So they cancel out. So what's left? Except the 1, and the 1 times x minus 4, x plus 3. So I have x minus 4 times x plus 3. And this side, let's see, x plus 3, x plus 3, x minus 3, x minus 3. So I have negative 2 times x. Well, forget about the 1. Right? Divided by 1 doesn't change anything. Multiply by 1 doesn't change anything. So we can ignore them. I multiply this, we have x times x squared, negative 4 times negative 3, and negative 4x, 3x. So we got x squared, negative 4 plus 3, negative 1. Negative 4 times 3, negative 12. Then move negative 2x to the other side, become positive 2x equals to 0. Remember how to resolve quadratic equations? So you see the beauty of this is from A, the rational expression all of a sudden change to be linear, right? Change to be linear. And for this C, the rational equations now all of a sudden becomes polynomial equations. So that's the beauty of multiplying and figuring out LCD, then multiply every term with LCD. So combine like terms, we got x squared minus x plus 2x, that's a plus x minus 12 equals 0. Well, this can be factored. That's x plus 4, x minus 3. Right, because positive 4 minus 3, that's positive 1. Positive 4 times negative 3, that's negative 12. So by zero property, x plus 4 might be 0, x minus 3 might be 0. X plus 4 means negative 4 is a solution. X minus 3 equals 0, and negative 3 is a solution. So there are two solutions. Oh, hold on a second. Hold on a second. Sometimes we need to go back to check. Right. Sometimes this method will cause something called extraneous root, which means a fake root. You see, in this case, 3 won't work. Why? You see, we have 3 squared. Well, 3 squared minus 9. 3 squared is 9. 9 minus 9 will cause 0. So we will reject this one. 3 can be a solution, but 4 will be a solution. So we only have one solution, x equals negative 4. And this one, you may check also, negative 6. Yes, negative 6 works. Because it won't cause, as long as the denominator is not 0, we're fine. We can never have the denominator to be 0. That's just illegal in mathematics. Now let's move up a little bit. So, E and D. Okay, for B, we see the least common denominator. It's just x minus 3, right? Just one factor. So you have to train your eyes or your brain to think of this as a factor. Right? You can put a parenthesis around to think about that. So we're going to do the same thing. We're going to multiply every term by the least common denominator. And of course, you can do, other ways. But I'm going to show you this way. I think this way is a bit, it's neat. I'm going to multiply by x minus 3 for every term. For every term. Because I have equation, I can do that. And of course, this is just a numerator. Now I have x minus 3 in the denominator, x minus 3 in the numerator. Those two cancel. I'm left with 2x divided by 1. So, but I just read as 2x. And this denominator, this numerator canceled. I have 2 divided by 1. So 2. Then I have negative 2 times x, which is negative 2x. Negative 2 times negative 3, positive 6. See, all of a sudden I get a linear expressions because I have got rid of the denominators. Now I move negative 2x to the other side. I had the 2x already. Now plus 2x. That equals to 2 plus 6, which is 8. So 2x plus 2x is 4x. Equals to 8. Divided by 4 on both sides. X equals to 2. For x is 2, that's fine. It won't cause 0 in the denominator. So this is a solution. Now let's see D. D, this denominator is x plus 2. This denominator is x minus 2. And what is x squared minus 4? X squared minus 4 is exactly x squared minus 2 squared. Difference of 2 squares is x plus 2 and x minus 2. So we're going to do the same for every term. We're going to multiply by LCD, which is x plus 2 times x minus 2. Right? X minus 1 divided by, well, x squared minus 4 is just x plus 2 times x minus 2. Now let me change my color. I'm going to multiply every term with my LCD. So this is my LCD. Multiply by x plus 2 times x minus 2 minus x minus 2 x plus 2. Yeah, I multiply everyone with the same thing. Again, because I have equation, I can do that. Well, these two canceled, so I'm left with 2 times x minus 2. X minus 2 canceled, so I have plus 4 times x plus 2 equals to this numerator, I have x minus 1. Then x plus 2 cancel x plus 2, x minus 2 cancel x minus 2. I'm left with x minus 1. Now distribute. I have 2x minus 4. Distribute 4 plus 4x plus 8 minus x. I'm moving x. I'm moving x to, oh, let's rewrite it. So equal to x minus 1. Right? Simplify. I have 2x, 4x, that's 6x. I have negative 4, positive 8, that's positive 4. That's equals to x minus 1. I move x to the other side, move 4 to this side. 6x minus x equals to minus 1 minus 4. 6x minus x, that's 5x. Minus 1 minus 4 becomes minus 5. So divided by 5 on both sides, x equals to negative 1. Well, negative 1 won't cause any denominator to be 0. So this is the solution. And that's it. So that's today's material, and I will see you in class.